The solar system has existed for almost 5 billion years. During this time, it has brought forth 8 planets, hundreds of moons, billions of asteroids, and countless comets. And out of all this grand estate, only one planet, one of 8, is covered with liquid water on almost 3/4 of its surface. One planet where water did not freeze, did not evaporate, did not fly off into space, but remained. It splashes, it storms, it nourishes life. This is not the norm. This is a statistical curiosity. This is something that, according to all calculations, should not be. Mars today is a rusty desert with an atmosphere thinner than cigarette paper. But 3 to 4 billion years ago, it was different. Rivers flowed across its surface, a shallow sea splashed in the north, and clouds moved in the sky. Then everything disappeared. Not gradually, but immediately. By geological standards, almost instantly. And now, nothing remains of that water except barely perceptible traces in minerals and dry canyons resembling scars from long-healed wounds. Venus is a planet of the same size as Earth, formed at about the same time from the same material. There, too, water could once have existed, perhaps even oceans. Today, it is a hell with a surface temperature at which lead flows like water, with atmospheric pressure capable of crushing a submarine, and with a sky overcast by clouds of sulfuric acid, not a drop of water. And Earth stands between them, literally between these two dead worlds, and it has oceans. This is not just a beautiful fact for a geography textbook. This is a mystery that scientists cannot fully solve to this day. Where did this water come from? How did it get here? Why did it stay here when its neighbors lost it? And the most uncomfortable question, was it always here, or did it arrive from the depths of the solar system, like a package from an unknown sender? We will break this story down to the molecules, literally to specific molecules, because the answers are hidden in them. We will look at the evidence that scientists have gathered for decades in meteorites, in comets, and in the Earth's interior. We will examine why every version that seemed final eventually turned out to be incomplete. And in the end, you will understand that the story of water on Earth is not just planetary science. It is a detective story about how the conditions for life arise at all. If you are interested in how the universe actually works, not in textbooks, but in reality, with all its paradoxes and uncomfortable questions, subscribe to the channel and give it a like. Such videos come out regularly, and it would be a shame to miss them. So, let us start with the most obvious question, to which, as it turns out, there is no obvious answer. Why is Earth so wet? 71% of the planet's surface is covered with water. The average depth of the world ocean is almost 4 kilometers. The deepest point, the Mariana Trench, goes down almost 11 kilometers. If you took all the water on Earth and gathered it into a ball, you would get a sphere with a diameter of approximately 1,400 kilometers, slightly smaller than the planet Pluto. It sounds like a lot, but wait. Now we will turn this picture upside down. By cosmic standards, Earth's water is insignificantly little. Not an exaggeration. Not a metaphor, literally insignificant. If you take all the water on Earth and compare it with the mass of the planet itself, you get a share of less than 1%. Earth is a rocky planet, and there is incomparably more rock in it than water. Water is just a thin film on the surface of a huge stone ball. But the problem is not the amount of water. The problem is that it exists at all. Look at our neighbors. Mercury, the planet closest to the sun, is a scorched stone ball without an atmosphere, where on the sunlit side the temperature rises above 400 degrees Celsius. Water cannot exist there in principle. Only in the eternal shadows of craters and poles do tiny ice deposits hide. Sunlight does not reach there. This is not the planet's water. These are fragments of comets brought there, stuck in the shade. Venus is next. Almost Earth-sized, almost Earth mass. It has an atmosphere, and what an atmosphere! 90 times denser than ours. But there is no water. All of it flew off into space long ago. We will get to the reasons later, because the story of Venus deserves a separate analysis. Mars, the red planet, which we have been studying with probes and rovers for several decades. There is water on Mars, but only in the form of ice at the poles and beneath the surface. There is no liquid water on the surface. The atmospheric pressure is so low that liquid instantly boils or freezes. Mars is a world where water exists, but living in it is impossible. And further out are the gas and ice giants: Jupiter, Saturn, Uranus, Neptune. There is plenty of water there, but it is locked in clouds, mixed with ammonia, buried under hundreds of kilometers of atmospheric pressure. There may be more water there than in the entire Earth's ocean, but it is absolutely inaccessible to life in our understanding. Earth, against this background, looks like an exception to every rule. Firstly, it has liquid water right on the surface, not under ice, not in the atmosphere, not under hundreds of atmospheres of pressure, just an open ocean under an open sky. Secondly, this water is stable. For billions of years, it has not flown off into space and has not frozen completely. Thirdly, there is enough of it to cover most of the planet. These are three separate miracles, each of which requires its own explanation. But before we start looking into the causes, another question must be asked. Where exactly are we looking when we talk about water in the solar system? There is one detail usually overlooked when talking about Earth's dry neighbors. The solar system is actually full of water, just not where we are used to looking for it. The moons of Jupiter and Saturn, Europa, Enceladus, Ganymede, hide entire oceans of liquid water under ice shells. Europa, for example, contains more water than all Earth's oceans combined. It is just that this water is covered by tens of kilometers of ice and never sees sunlight. Comets at the edges of the solar system are essentially flying snowballs made of ice and dust. The Kuiper Belt and the Oort cloud are giant refrigerators stuffed with frozen water. Water is everywhere, but in liquid form, on the surface, under the open sky, only here. Why exactly here? When scientists began seriously searching for the answer to this question, they discovered that the story is much more complicated than it seemed, because Earth, by all calculations, should not have received so much water. It formed in a place in the solar system where water simply could not exist in solid form, which means it could not be part of the building material from which the planet was assembled. And this is where the real detective story begins. To understand where the water on Earth came from, we need to go back 4.5 billion years. To a time when the solar system did not yet exist, there was only a huge cloud of gas and dust, a protoplanetary disk slowly rotating around the young sun. Imagine a giant pizza, not round and neat, but blurred, extending in diameter to the size of several light years. In the center is the young, still unstable sun, which is gradually heating up, and around it are rings of dust, gas, and ice. From this material, planets will be assembled. Now the key point. Not all the disk's matter is the same. Where the temperature is high, closer to the sun, volatile substances evaporate. Water, carbon dioxide, methane. None of this can exist in solid form at high temperatures. Therefore, in the inner part of the disk, the building material for planets is mainly silicates and metals, stone and iron, dry, hot material. And somewhere at a distance of about 2.5 astronomical units from the sun, this is between the orbits of Mars and Jupiter, a boundary passes. It is called the snow line. Beyond it, the temperature drops so much that water freezes and can be part of planetesimals, the embryos of future planets. It was beyond this line that the ice giants and water-rich asteroids formed. Earth formed inside this line, at about 1 astronomical unit from the sun, deep in the dry zone. By all laws of planet formation, Earth should have grown from dry, stony material. And at first it was so. The primary Earth was hot, dry, and devoid of water in significant quantities. But that is not all. Even if we assume that some water did enter the composition of the primary Earth, bound in minerals, in crystal lattices, it should have disappeared because the early Earth survived several events capable of evaporating anything. First, the formation of the planet itself. When thousands of planetesimals collide with each other and merge into one body, a colossal amount of heat is released. The kinetic energy of collisions turns into thermal energy. The young Earth literally melted. The entire surface was a magmatic ocean, a molten stone sea hundreds of kilometers deep. Any water at such temperatures immediately evaporates and flies off into space. Second, the solar wind. Young stars are significantly more active than mature ones. The young sun emitted powerful streams of charged particles, literally blowing light molecules off the surface of planets. This is why the primary atmospheres of the inner planets were destroyed and replaced by secondary gases erupting from the depths through volcanoes. Third, the hypothetical Theia impact. Approximately 50 to 100 million years after the formation of Earth, a body the size of Mars crashed into it. This impact was so monstrous that it ejected a huge amount of material into space, from which the Moon later formed. The energy of this collision melted the entire Earth again. Again, a magmatic ocean. Again, total destruction of any volatile substances on the surface. After all this, Earth should have been an absolutely dry, sterile stone ball, without a hint of water. But then something strange happened. Somewhere around 4 billion years ago, geologists call this period the Hadean Eon, and the name was not chosen by chance. The first stable zircon crystals began to appear on Earth. These are incredibly hard minerals capable of surviving for billions of years, and in these ancient crystals, scientists found an isotopic composition characteristic of minerals formed in the presence of liquid water. Do you understand what this means? Already 4 billion years ago, almost immediately after all these catastrophes, there was liquid water on Earth. It came from somewhere, but where? To answer this question, scientists came up with an elegant tool. They began to read the history of water by its molecular composition, more precisely, by the ratio of two types of hydrogen atoms. Ordinary hydrogen is the simplest atom in the universe. One proton, one electron. But he has a heavy twin brother, deuterium. Deuterium differs in that its nucleus contains not only a proton, but also a neutron. Because of this, it is twice as heavy as ordinary hydrogen. When water forms under different conditions at different temperatures in different parts of the solar system, the ratio to ordinary hydrogen turns out to be different. The colder the conditions of formation, the more deuterium the water molecule captures. This is a kind of thermometer built into the molecule itself. Water in the asteroid belt, in those cold, dark lumps between Mars and Jupiter, has one ratio. Water in comets coming from even more distant and colder regions of the solar system has another, and water in Earth's oceans has its own. When in the 21st century scientists began to mass measure the deuterium composition of different cosmic sources of water, they expected to find a simple answer. Either Earth's water would match comet water, and that's it. Comets delivered the water, or it would match asteroid water, meaning the source is in the asteroid belt. It turned out to be more complicated. Comets were the first to fall under suspicion. The logic seemed ironclad. Comets are flying snow blocks. Their nuclei consist of ice, frozen gases, and dust. Comets regularly fall on planets. Why shouldn't they be the source of Earth's water? This version began to be checked with special care when in 2014, the Rosetta spacecraft reached comet Churyumov-Gerasimenko and began to analyze its composition. This was one of the most complex and expensive missions in the history of European astronautics. The craft flew for 10 years to the target, entered orbit, and lowered a landing module. Scientists were waiting for confirmation of the comet version. The results disappointed them. The deuterium ratio of the water on comet Churyumov-Gerasimenko turned out to be about 3 times higher than in Earth's oceans. This is a huge difference. This is like comparing table salt with seawater. Formally, both have sodium, but it is not the same thing at all. Comets from the Oort cloud, in the farthest part of the solar system, on average show a similar result. Their water is too rich in deuterium to be the source of Earth's oceans. The comet hypothesis in its pure form does not work. But then something interesting happened. In March 2024, Comet Ponce-Brooks passed by Earth, one of the few so-called short-period comets from the Halley family. This is a different class of comets than Churyumov-Gerasimenko. They originate not from the Oort cloud, but from intermediate regions of the solar system. Astronomers took the opportunity and analyzed its composition and discovered something unexpected. The deuterium ratio of water in Comet Ponce-Brooks turned out to be significantly closer to Earth's than in most studied comets. Not a perfect match, but close enough to raise the question again. Could comets have played a role after all? Just not all comets, but a certain type. The picture became confused again. And while scientists argued about comets, data was simultaneously accumulating in favor of a completely different source, more earthly, darker, and perhaps more important. Between the orbits of Mars and Jupiter lies the asteroid belt, a ring of millions of stone bodies of different sizes, from dust motes to lumps with a diameter of several hundred kilometers. Most of them are ordinary stone or metal fragments, but there is a special class among them, carbonaceous chondrites. Carbonaceous chondrites are not just stones. They are the oldest objects in the solar system, preserved since the moment of its formation. They contain organic molecules, amino acids, and most importantly for us, water. Not in liquid form, of course. The water in them is chemically bound, embedded in the crystal structure of minerals, but upon collision with a planet and heating, it is released. When scientists began to measure the deuterium ratio in carbonaceous chondrites, they found a striking thing. It practically perfectly matches Earth's. Not close, it specifically matches within the measurement error. This became a sensation in planetary science. Here they are, the sources of Earth's water. Not comets from the far edge of the solar system, but asteroids from the belt beyond Mars. Mainly so-called C-type asteroids, carbonaceous, dark, water-rich bodies from the outer part of the asteroid belt. The Carnegie Institution in Washington conducted a large-scale study in which 85 meteorites, samples of carbonaceous chondrites that fell to Earth at different times, were analyzed. Isotopic analysis showed a match not only for water, but also for a whole range of other elements, nitrogen, noble gases. Everything pointed to one thing. The main source of water on Earth is asteroids from the outer part of the belt. But here the next question arises. Asteroids do not move toward Earth by themselves. They sit in their belt for billions of years in stable orbits. For an asteroid to fall to Earth, something must knock it out of orbit. Something must disturb this order. And this something is well known to science. Approximately 3.5 to 4 billion years ago, the solar system was shaken by an event that geologists called the Late Heavy Bombardment. This was an era when the inner planets were subjected to continuous shelling by asteroids and comets. The Moon, which has preserved the history of its surface better than Earth, is literally pitted with craters from that period. Most of the lunar Maria, the dark spots on its surface, were formed then. Earth received no less. It is just that its surface has since been many times reworked by tectonics and erosion, and the traces have not survived. Where did this bombardment come from? Why then? The answer was not found immediately. A version was proposed by a group of scientists gathered at the Nice Observatory in southern France, hence the name of their model, the Nice model. According to this model, in the early solar system, the gas giants occupied different orbits. Jupiter was closer to the Sun, Saturn too. Then, approximately several hundred million years after the formation of the system, the orbits of the giants began to change. Jupiter and Saturn passed through an orbital resonance, a moment when their orbital periods began to coincide in multiples. This destabilized the entire system. Uranus and Neptune were thrown into more distant orbits, crumpled the Kuiper belt, and billions of objects flew in all directions, including toward the inner planets. It was during this period, during the late heavy bombardment, that a significant amount of water crashed onto Earth according to calculations. Carbonaceous chondrites and other water-containing bodies, knocked out of their stable orbits by the gravitational reorganization of the system. But the mystery, nevertheless, is not fully solved, because according to some calculations, the bombardment explains only part of Earth's water. The rest should have appeared earlier, even before the bombardment. And here the main suspect in this story enters the scene. A planet without which the story of Earth's water would have been completely different. A planet that we are used to considering a protector, but which upon closer inspection turns out to be a much more complex character. Jupiter. For many years, a simple and beautiful story dominated popular literature. Jupiter is our shield, the gravitational vacuum cleaner of the solar system. With its colossal gravity, it attracts asteroids and comets that would otherwise fly toward Earth, and either consumes them or throws them out of the system. Without Jupiter, Earth would receive impacts thousands of times more often. Life would be impossible. It would all be over. This story was told in documentaries, in textbooks, in popular articles. It seemed logical and complete. Then scientists took computer models and checked it for real. It turned out that everything is significantly more complicated. Yes, Jupiter really intercepts some of the objects that would otherwise fly past or fall on the inner planets. This is true, but Jupiter's gravity works not as a shield, but as a slingshot. It does not consume objects, but changes their trajectories, and sometimes it directs objects not away from the inner planets, but directly toward them. Research by Kevin Walsh's group from a NASA institute showed something unexpected. Jupiter in the early period of its history migrated, moving closer to the Sun and then returning back. This movement is called the Grand Tack. In the course of this migration, Jupiter passed through the outer asteroid belt and physically mixed it. Some of the asteroids were thrown onto unstable orbits crossing the paths of the inner planets, including carbonaceous chondrites. In other words, it was Jupiter that directed toward Earth those very water-containing asteroids that brought water. Without its migration, these water-rich bodies would have remained in their belt, never approaching Earth. A total paradox. Jupiter, which we considered a shield, is simultaneously a water carrier. And now let's add another layer to this story. The late heavy bombardment we talked about is also largely explained by the behavior of Jupiter and Saturn. The NICE model describes exactly the resonance of these two planets as the trigger for global destabilization. Jupiter and Saturn arranged such a shuffle in the solar system that billions of bodies flew in different directions, and some of them brought water to Earth. Saturn in this picture is not just a beautiful planet with rings. It is a necessary partner in the gravitational dance. If not for Saturn, Jupiter would not have entered resonance and would not have returned back after migration. Without this return, Jupiter could have flown too close to the Sun and completely destroyed the orbits of the inner planets. According to one version, it was the joint resonance of Jupiter and Saturn that saved Earth from destruction and simultaneously launched the very bombardment that brought water. So we have a source, carbonaceous chondrites. We have a delivery mechanism, Jupiter's migration and the late bombardment. There is isotopic evidence. The story seems to fit together, but one question remains that gives no peace. Everything we talked about, asteroids, comets, bombardments, are external sources, water brought from the outside. But what if part of the water was here initially? What if it didn't fly anywhere during the planet's formation? but on the contrary was safely hidden inside in the deepest depths, from where it then slowly came out to the surface. It was this question that led scientists to one of the most unexpected discoveries of recent years. A discovery that forced a reconsideration of the very idea of what Earth's water is and where its true home is. In 2014, a group of Canadian and American scientists published a paper that quietly, without loud headlines, overturned the idea of where water lives on Earth. They were studying a tiny brownish crystal brought to the surface, along with a diamond from a depth of more than 700 kilometers. The mineral was called ringwoodite, a material well known to scientists in itself, a close relative of olivine, common in the upper mantle. But this specific sample contained something unexpected: water, chemically bound, embedded in the crystal lattice, but unequivocally water. Hydrogen and oxygen atoms built directly into the structure of the mineral like raisins, not as drops, not as puddles, but as molecules scattered throughout the entire crystal grid. It sounds like a curious mineralogical fact until you realize the scale. The transition zone of the mantle, the layer from 400 to 700 kilometers deep, is not a thin layer. It is a colossal volume of rock surrounding the entire globe. If this entire layer contains ringwoodite with the same water saturation, the total reserve of hidden water exceeds the volume of the world ocean. According to some calculations, by 3 or even 5 times. Under our feet, 700 kilometers down, an additional ocean exists. Invisible, non-liquid, locked under pressure of millions of atmospheres at temperatures that melt steel. No, chemically, it is real water. However, ringwoodite is only one floor of this underground storage. Below begins the lower mantle, where the pressure is even higher, the minerals are different, and the main one is bridgmanite. This is the most common mineral of the Earth by volume. It accounts for almost 40% of the total mass of the planet. For many years, it was believed that bridgmanite practically does not hold water. The structure is too dense. Molecules simply have nowhere to fit. In 2025, nothing was left of this certainty. A group from ETH Zurich, the Swiss Federal Institute of Technology, conducted a series of experiments with diamond anvil cells. This is a device in which 2 diamond tips press on a sample with monstrous force, reproducing the pressure of the Earth's depths right on the laboratory table. By squeezing bridgmanite samples to the pressures of the lower mantle and heating them to several thousand degrees, the scientists saw, under certain conditions, bridgmanite captures hydrogen not as a water molecule, but as individual atoms sewn into the crystal lattice. Hydrogen is half of a water molecule. When such material rises to a zone of lower pressure, the hydrogen atoms are released and immediately react with oxygen, giving water. The mechanism is slow, but it works. This means that the lower mantle is another colossal reservoir. If bridgmanite throughout the lower mantle is saturated with hydrogen by even a fraction of a percent, the total hidden reserve of water exceeds all surface oceans tens of times. Some calculations, including hydrogen in the core itself, call figures that are altogether fantastic, from 9 to 45 volumes of the Earth's oceans. Earth is not a stone ball with a thin film of water. It is a thoroughly wet body, saturated with water at all levels, from the surface ocean to the metallic core. And this water does not stand still. It moves. When an oceanic plate goes under a continental one, in a process geologists call subduction, it drags with it seawater that has saturated the basalt of the seabed. At depths of about 100 kilometers, pressure and heat squeeze part of this water back up, provoking the melting of mantle rocks and the birth of volcanoes. That is why the volcanoes of the Pacific Ring of Fire stand where oceanic plates plunge under continents. But part of the water slides even deeper, into ringwoodite, into bridgmanite, becoming preserved for millions of years, and then returns through mid-ocean ridges, hot spots like the Hawaiian Islands, volcanic arcs, down along the plates, up through volcanoes. a slow, continuous, eternal rotation on a time scale of hundreds of millions of years. Now a twist that changes the whole picture. If ringwoodite and bridgmanite store water at such pressures and temperatures, and if these minerals have existed since the formation of the Earth, then perhaps a fundamentally different story is true. Water did not arrive from the outside. It was absorbed by the planet at birth, captured by Earth's embryos even in the protoplanetary disk. While the surface melted in a magmatic hell, water sat in the depths, in a crystal prison, and waited. Then the planet cooled. Convection reshuffled the contents of the mantle. The deep water cycle began to slowly raise water to the surface. Volcanoes exhaled steam. Steam condensed. It rained. According to this version, external bombardment is not the main supplier, but an additional contribution. The main mass of water was always here. But here the question arises that immediately complicates the picture. If the water was in the depths from birth, the depth protects it. Pressure holds it. Now, when it finally came out to the surface through volcanoes, what kept it there? The young sun actively attacked the atmosphere. The solar wind scattered molecules. Any gas escaping to a height risked being carried off into space forever. What stood between Earth's water and the abyss? Right now, while you are listening to this, an invisible shield is working around the Earth. It has no color, does not cast a shadow, and cannot be touched. No, it is one of the main reasons we exist. Earth's magnetic field. It extends tens of thousands of kilometers into space, distorting the space around the planet into the shape of a teardrop. Compressed on the side of the sun, stretched into a long tail on the opposite side. Streams of charged particles flying from the sun at a speed of several hundred kilometers per second hit this field and are deflected. They go around the planet, passing by. Without this field, the solar wind would methodically bombard the upper layers of the atmosphere, knocking out molecules one by one. Slowly, but unstoppably. This is exactly what happened to Mars. 4 billion years ago, Mars was a different planet. Magnetized stripes in its oldest rocks, in the oldest geological formations of the southern hemisphere, say that it also had a magnetic field. While it worked, Mars held a dense atmosphere. Under it, pressure was maintained sufficient for liquid water. Rivers flowed across the surface. A shallow sea splashed in the north. Mars was alive. Then the field faded. The reason is simple and ruthless. Size. Mars is 10 times lighter than Earth. Smaller volume, smaller reserve of radioactive heat. Less heat, the mantle cools faster. The mantle cools faster, the core solidifies earlier. When the core solidified and convection stopped, the magnetic dynamo stopped. Mars lost its shield. Next, one scenario. The solar wind gained direct access to the atmosphere. Charged particles began to ionize the upper layers, accelerating molecules to speeds above the escape velocity. The atmosphere decreased, pressure fell. Water on the surface ceased to be liquid, boiled and froze simultaneously, rising as steam. Ultraviolet light split water molecules into hydrogen and oxygen. Light hydrogen flew off into space irrevocably. Oxygen settled on the surface, oxidizing iron in the rocks. This is why Mars is red. The planet literally rusted from the inside. The MAVEN mission, a NASA probe working in orbit around Mars since 2014, measured the rate of this loss in real time. According to its data, Mars is losing its atmosphere right now. Over geological eras at such a rate, the planet lost an atmosphere that was once quite comparable to Earth's. Earth escaped this because it did not cool down. Earth's dynamo has been working for 3.5 to 4 billion years. Molten iron in the liquid outer core moves in convective flows. Hot rises, cooled sinks. The rotation of the Earth twists these flows. Moving molten iron is an electric current in a giant conductor. The current generates a magnetic field. The system maintains itself. As long as there is heat, as long as there is convection. And Earth has heat. Radioactive elements in the depths, uranium, thorium, a long-lived isotope of potassium, continue to decay, releasing heat. Plus the residual heat from the formation of the planet and from the Theia impact, which has still not dissipated. Earth is a slow-motion thermonuclear reactor that heats itself from within, and there is enough of this heat for billions of years to come. Thanks to this, the liquid outer core did not freeze. Convection did not stop. The dynamo did not stop. The magnetic shield has stood for 4 billion years. During this time, not a single water molecule has flown off into space simply because it was blown away by the solar wind. But there is a nuance. The magnetic field protects the atmosphere from direct stripping. This is a fact. However, this in itself does not guarantee that water will remain liquid. You can have an atmosphere and still lose all the water if the climate goes crazy, if the temperature starts to rise without stopping. For this not to happen, not a shield, but a regulator was needed, not armor, but a thermostat. If the magnetic field is the walls of a house keeping the weather outside, then plate tectonics is a heating system with automatic adjustment. Without walls, it is cold, but without regulation, you either freeze or burn. Plate tectonics. A phenomenon we are used to taking for granted is a rarity on the scale of the solar system. Neither Mars, nor Venus, nor the Moon, nor any moon we know has full-fledged plate tectonics. Earth, in this respect, is currently unique among all studied solid bodies. What is tectonics in its simplest form? Earth's crust is broken into several dozen rigid plates. They slowly move along the plastic upper layer of the mantle, moving apart, colliding, diving one under another. The speed is centimeters per year, comparable to the growth rate of fingernails. But over billions of years, these centimeters add up to a completely reshaped surface of the planet. For water, tectonics is important for two reasons. Both are fundamental. First, subduction as a water conveyor. Plates plunge, carrying seawater into the mantle. Volcanoes return it to the surface. This pump works continuously, holding the balance between water in the depths and water on the surface. The second reason is more important and subtle. Tectonics is the planet's carbon thermostat. It was what prevented Earth from repeating the fate of Venus. Here is how it works. Volcanoes release carbon dioxide, a greenhouse gas that traps heat. If this were the only connection, the planet would have long since overheated. Volcanoes work constantly, but there is feedback. When the temperature rises, precipitation intensifies. Rainwater is a weak acid. It reacts with carbon dioxide, forming carbonic acid, which washes calcium out of rocks. Calcium with carbonic acid settles on the ocean floor in the form of carbonates, limestone. When a plate with this limestone goes into subduction, the carbon dioxide ends up in the mantle again. Through a volcano, it returns to the atmosphere. The cycle is closed. This cycle works as a regulator. Too warm, more rain, more carbon dioxide washing out, less greenhouse effect. The planet cools. Too cold, rain weakens, carbon dioxide accumulates, it gets warmer. The planet corrects itself slowly, on a scale of millions of years. No, it was this that kept the climate in the liquid water zone for almost 4 billion years. Venus is devoid of this mechanism. There is no subduction there. The surface behaves like a single rigid shell. Because of this, the washed-out carbon dioxide has nowhere to go, and volcanoes continue to throw out new gas. The result is predictable. The greenhouse effect accelerates without breaks. Without tectonics, Earth today would be either a frozen ball or a red-hot hell. In neither case would there be any talk of a liquid ocean. However, tectonics and the magnetic field are still not the full answer, because there is another element of the system that is easily dismissed as scenery. People almost never think about it seriously, and they should. Without it, Earth's climatic stability would fall apart like a house of cards in the wind. If you look at the moon objectively, without habit, it becomes unsettling. It is too large an object. The moon is 27% of the size of Earth. There is no such ratio anywhere else in the solar system. No satellite of a rocky planet comes close to such a share of its host's size. This anomaly requires explanation. The prevailing theory is a giant impact. Approximately 50 to 100 million years after the formation of Earth, an object the size of Mars, which scientists called Theia, crashed into it. The impact ejected a huge cloud of molten substance into space, a mixture of the mantle materials of Earth and Theia. This cloud spun around the Earth and stuck together into the Moon. According to this theory, the Moon literally consists of us. The isotopic composition of lunar rocks matches Earth's almost perfectly. And this is one of the strongest confirmations of the impact theory. But we are not talking now about the origin of the Moon, but about what it does for water. First and foremost, the Moon stabilizes the tilt of the Earth's axis. Earth's axis is currently tilted at about 23.5 degrees. It is this tilt that gives us the change of seasons. It oscillates slightly within a range of several degrees over cycles of tens of thousands of years. Small oscillations, and the climate also changes accordingly, which we know from the ice ages. What would happen without the Moon? Mars is a good example. It has no large satellite, and its tilt axis over billions of years has wandered from almost 0 to 60 degrees and more. These are catastrophic changes. At a tilt of 10 degrees, one climate. At a tilt of 50, the poles end up where the tropics are now. Climatic zones are completely rebuilt. No stable water cycle is possible under such conditions. The Moon is a gravitational anchor, not letting the Earth's axis dangle within these dangerous limits. Its mass is sufficient to use its gravity to damp precession, holding the tilt in a narrow range. Without the Moon, the Earth's axis could have deviated by tens of degrees over billions of years. A stable ocean under such conditions is a big question. The second action of the Moon is tides. Lunar gravity raises ocean waters twice a day. Today, this is perceived as background noise. Well, tides are beautiful. But in the deep past, when the Moon was much closer to Earth, its gravity raised the ocean by tens of meters. The Moon is slowly moving away from us, about 3 to 4 centimeters per year. Several billion years ago, it hung significantly closer, and the tides were monstrous. These giant tides mixed the water on a planetary scale. Deep, cold layers rose to the surface. Warm surface layers went down. This created intense circulation, equalizing the temperature throughout the entire ocean. Without this mixing, tropical waters could have overheated and evaporated, and polar waters could have frozen to the bottom. There is another hypothesis, much bolder but well-founded. The first organisms that came out of the water onto land about 400 million years ago had to learn to live in conditions of variable moisture. Tidal zones, strips of shore, sometimes flooded, sometimes exposed, were the ideal school for this transition. A rhythm was needed, and the Moon gave this rhythm twice a day, every day for hundreds of millions of years. So the magnetic shield holds the atmosphere. Tectonics regulates the climate. The Moon stabilizes the axis and mixes the ocean. Now it all fits? Not quite, because all the listed are conditions for preserving water. No, before preserving it, one had to be in exactly the place where the temperature does not kill everything at once. There is the concept of the habitable zone, the region around a star where liquid water can theoretically exist on a planet. Sometimes it is called the Goldilocks zone, not too hot, not too cold. Earth is in this zone. It would seem everything is simple, but upon closer inspection, Earth sits at the very inner boundary of this zone, almost on the edge. Move Earth 10 to 15% closer to the Sun, and we get Venus. Move it 15 to 20% further away, the planet is covered in ice. Ice reflects sunlight. This cools the planet even more, which increases the ice. A vicious circle from which there is no independent exit. The corridor in which water remains liquid is narrow, but here is hidden a paradox that is rarely talked about. 4 billion years ago, the young sun shone about 30% weaker than it does now. According to all calculations, at such luminosity, Earth should have been completely covered with ice constantly. Scientists even came up with a name for this state: Snowball Earth. No, it did not freeze. Rocks of that age contained traces of liquid water, those very zircons from the beginning of our conversation. Their isotopic composition unequivocally points to the presence of liquid during formation. The early Earth was warm despite the faint sun. The explanation was found in the atmosphere. The early atmosphere of the Earth was significantly richer in carbon dioxide and methane. These gases were enough for the enhanced greenhouse effect to compensate for the faint solar radiation. The planet warmed itself with its own atmosphere. Too few greenhouse gases, it freezes. Too many, unstoppable heating will begin. And here again, the tectonic thermostat held this balance for billions of years. As the sun gradually flared up, tectonics slowly removed excess carbon dioxide from the atmosphere. The planet adapted, not noticing the changes. Liquid water on the surface is not just a result of the correct distance from the sun. It is a result of constant active regulation. The planet held itself in the right state for almost 4 billion years. To understand how fragile this balance is, one needs to look at the planet that started with the same conditions, which was almost identical to us and which still lost everything. Venus is Earth's closest neighbor and, by ironic coincidence, the planet most similar to it. One size, one mass, identical geological origin. If there were a concept of twin planets in the solar system, Earth and Venus would be exactly them. No, look at them now. On Venus, the surface temperature is about 460 degrees, always around the clock, both at night and at the poles. Atmospheric pressure at the surface is 90 times higher than Earth's, like diving almost a kilometer into the depths of the Earth's ocean. The sky is overcast with thick clouds of sulfuric acid and not a drop of water. How did this happen? Once, perhaps 2 to 3 billion years ago, Venus was probably different. Computer climate models developed at NASA and a number of European institutes show, under certain initial conditions, Venus could have been habitable, with a moderate climate, with liquid water, possibly with shallow oceans. A few billion years is enough for life to arise. Then something started the acceleration. The exact trigger is unknown. Possibly an increase in volcanic activity. Possibly a gradual increase in the brightness of the sun. And Venus has no compensating carbon cycle, no subduction. Maybe a random chain of events, but the result is the same. The temperature began to rise. When the temperature rises, the ocean evaporates more intensively. Water vapor is also a greenhouse gas. More vapor, warmer. Warmer, more evaporation. More evaporation, more vapor. A self-reinforcing mechanism. It cannot be stopped from the inside. Once started, there is no turning back. The planet heated up to the limit. All surface water evaporated. Now, where did the water itself go? It cannot just disappear. This is where a mechanism comes in that is almost never told in popular texts. When the atmosphere warmed to critical temperatures, water stopped condensing and falling as rain. Instead, it rose to the upper layers, where ultraviolet light split the molecules into hydrogen and oxygen. Hydrogen is light. Venus did not hold it. Oxygen entered into reactions with atmospheric gases, giving ions that also flew off into space under the action of the solar wind, molecule by molecule. Over hundreds of millions of years, the water disappeared. If you distributed all the water that Venus could have had evenly over the surface, you would get a layer several tens of meters thick, shallow, but a real ocean. Today, there is only enough water on Venus for a film several centimeters thick. Everything else has dissolved in space. The difference between Earth and Venus is not in luck. The difference is that one turned out to have a working carbon thermostat, subduction, a magnetic field, and it held the water. The other did not have a single one of these mechanisms at the right time and lost everything. The story of Venus is a mirror. It reflects not someone else's catastrophe, but our own margin of safety. And when you look into this mirror for a long time, you begin to notice something disturbing. Too many conditions were met simultaneously for Earth's water to exist. Too accurately, everything is fitted. Jupiter in the right orbit, the moon of the right size, tectonics works, the magnetic field holds. The distance to the sun is ideal. Everything is too right. Here is a list of what must be simultaneously fulfilled for liquid water to exist on a planet. The planet must be the right size, large enough to preserve heat in the depths and maintain a magnetic field, but not so huge as to become a gas giant. It must be in a narrow corridor of distances from the star, neither closer nor further. Near it must be a massive giant planet that redirected water-containing asteroids in the right direction at the right period of history. This same giant planet should not have flown too close to the star and destroyed the orbits. The planet must have plate tectonics with a carbon thermostat. It must have an anomalously large satellite stabilizing the axis tilt. And on top of all this, an initial supply of water delivered at the right time with the right isotopic composition in the right quantity. Each of these points individually is already a rarity. Altogether, this is statistics that begins to raise uncomfortable questions. Let us talk about what in scientific articles is discussed cautiously and in footnotes, and in documentaries almost never, because it looks too much like what should not be in science. Among some researchers, there is a concept that can be called the targeted delivery theory. Not in a mystical sense. It does not imply any intent. The point is different. A number of scientists noticed that the water on Earth is too correct. Not just water, but water with a specific isotopic composition matching a specific class of asteroids, which, in turn, were redirected toward Earth by a specific migration of Jupiter at a specific period. Too many specificities in one sentence, too precise a chain. An alternative interpretation of this data looks like this. Maybe we are dealing not with an incredible coincidence, but with a pattern. That is, planets that form in systems with a gas giant in the right orbit almost automatically receive water of the right composition. The process is not random. It is determined by gravitational interactions. Where there is a Jupiter of the right size in the right orbit, their carbonaceous chondrites fly toward the inner planets. Not always, not inevitably, but statistically often. This is not a conspiracy theory. This is a hypothesis that some configurations of planetary systems are much more likely to produce habitable planets than others, and that our solar system may be one of such correct configurations. Here, the anthropic principle inevitably surfaces, one of the most controversial concepts in the philosophy of science. In its weak formulation, it sounds simple. We observe a universe with precisely such parameters because with other parameters, we would not be here to observe it. This is a truism, but a very powerful one. Earth is arranged so that there is life on it. Not because it is planned that way, but because only on such a planet can beings arise who will ask this question. In application to water, out of all the planets in the solar system, only Earth has liquid water on its surface. We live on this exact planet, not on Mars and not on Venus. Naturally, Earth's conditions seem normal and correct to us. Any intelligent being arising somewhere else would consider its habitat the norm. It sounds like an attempt to brush off the question, but it is not a brush-off. It is an indication of a real problem in our reasoning. When we say too many coincidences, we do so from the position of beings who already know the answer. We already live on Earth. This creates the illusion that the result was predetermined. A realistic look at all this is as follows. We do not know how rare our situation is. We have one data point, Earth. From one data point, statistical conclusions about the distribution cannot be made. We do not know how many planetary systems with a correct Jupiter are in the galaxy. We do not know what share of rocky planets in the habitable zone have plate tectonics. We do not even know for sure whether tectonics is mandatory for the emergence of life or just convenient. What we can say with certainty, Water on Earth is the result of a chain of events, each link of which was necessary. Remove one and something would have gone differently. Maybe completely differently. We do not know. No, here is what is interesting. This very question, how rare Earth is, has become one of the main drivers of astronomy over the last 20 years. Because if we want to understand whether we are unique, we need to look beyond the solar system. We need to look for water where no one expected it. And when they started looking, they discovered something that completely overturned the idea of where in the universe life can exist. Water is one of the most common molecules in the universe. This is not an exaggeration or a poetic image. It is a literal fact. Oxygen is the third most common element in the universe after hydrogen and helium. Hydrogen is the most common. They are found everywhere and inevitably form water under suitable conditions. Water molecules have been recorded in interstellar clouds, in gas nebulae, in protoplanetary disks around stars at a distance of thousands of light years. There is unimaginably much water in the universe. The problem is not the presence of water, the problem is its state. Look at the solar system. If you compiled a rating of objects by the total volume of water, Earth would not even make it into the top 5. Ganymede, the largest moon of Jupiter, and generally the largest moon in the solar system, contains more water than all Earth's oceans. Under its ice crust, about 800 kilometers thick, hides a salty liquid ocean. Callisto, another moon of Jupiter, a similar picture. Europa, 4 Earth oceans under the ice. And this ocean actively circulates, heated by tidal friction from Jupiter's gravity. Enceladus, a small moon of Saturn, only about 500 kilometers in diameter, turned out to be one of the most intriguing objects in the solar system. The Cassini probe recorded that geysers of water vapor and ice erupt from cracks in its south pole directly into open space. Under the surface is a warm liquid ocean with hydrothermal vents on the bottom. Hot water interacting with rock. Organic molecules in the composition of geyser emissions. By the standards of the search for life, a golden hit. Titan, Saturn's largest moon, is a whole different story. There is liquid on its surface that forms lakes and seas. Only it is not water. It is liquid methane and ethane at a temperature of about minus 180 degrees. This is different chemistry, a different environment, a different logic. Is it habitable? Unknown. Possibly, but certainly not like what we are used to. Now let us go beyond the solar system. Since the end of the 90s of the last century, astronomers have discovered thousands of exoplanets, planets around other stars. Among them are rocky planets in the habitable zones of their stars, planets of the right size, the right distance, the right density. TRAPPIST-1, a red dwarf 40 light-years from us, has a system of 7 rocky planets, 3 of which are in the habitable zone. Some of them are close to Earth in size and mass. Is there water on them? The James Webb Telescope has begun to analyze the atmospheres of these planets. So far, the results are ambiguous. No sure signs of water have been found in the atmosphere, although the search continues. This does not mean an absence of water. The telescope is limited in its capabilities, and subglacial oceans it, in principle, cannot detect. Here lies the key distinction that is important to remember. Water is everywhere in the universe. No, it is almost always either frozen or hidden under a layer of ice or locked in minerals. Liquid open water under the open sky is a rarity, maybe an exceptional rarity. In the solar system, such water is only on Earth. Nowhere else, on no moon and on no planet, is there liquid water accessible from the surface, washed by the atmosphere, heated by sunlight. It is in this that the true uniqueness of Earth lies. Not in that there is water here, it is everywhere, but in that this water is open, liquid, accessible, and stable for almost 4 billion years already. This is exactly that point where all the threads of our detective story converge. Let us gather everything together, because now that we have walked this path from the protoplanetary disk to Enceladus, from deuterium isotopes to Martian rust, the picture looks completely different than at the beginning. The question of where water came from on Earth turned out to be, in fact, a question of why Earth is arranged the way it is. Water here is not just a chemical compound, it is an indicator that the planet went through the correct combination of conditions and held them long enough. Earth has 7 conditions working simultaneously. Let's name them not as a list, but as a system. First, correct size, large enough to preserve heat in the depths for billions of years, maintain a liquid core and a working magnetic field. Mars turned out to be smaller and lost. Second, magnetic field. It stands between the atmosphere and the solar wind. Without it, the atmosphere decreases, water goes into space, the planet is stripped. On Earth, the dynamo has been working for almost 4 billion years, and no end to this is in sight for another several billion. Third, plate tectonics with a carbon thermostat, a living planet that breathes through volcanoes and swallows through subduction zones. The carbon cycle compensates for any temperature deviations on a scale of millions of years. Venus is devoid of this and has turned into hell. Fourth, correct orbit, a narrow corridor of distance from the sun in which water can be liquid. Earth is in this corridor, but at the very inner boundary. This is not perfectly centered, as it is sometimes drawn in textbooks. This is the edge. There is a margin of safety, but it is not infinite. Fifth, the moon. Too large a satellite, which appeared as a result of a catastrophic impact. It stabilizes the axis, supports ocean mixing, and creates a rhythmic tidal zone, a peculiar detail without which the system would work much worse. Sixth, Jupiter, a planet that we for a long time considered a shield, but it turned out to be a water carrier. Its migration reshuffled the asteroid belt and directed toward Earth exactly the bodies that carried water with the right isotopic composition. Without Jupiter in this orbit, with this history, water could have come in a completely different amount or not come at all. Seventh, water in the depths. Hidden reservoirs in ringwoodite and bridgmanite that worked as a buffer from the very birth of the planet. The deep water cycle as a pump, slowly raising water to the surface through volcanoes and receiving it back through subduction. This is an internal supply that does not depend on external bombardments and makes the system stable. All 7 conditions work like locks on one door. Remove one lock, and the water will either fly off or freeze, or turn the planet into a cauldron. All 7 must work simultaneously over billions of years. This tells us something important about the search for life in the universe. While we are looking for habitable zones, that very corridor of distances from the star, we are looking at only one of the 7 locks. We ask whether there is liquid water there, but we do not ask what holds it there. And this, as we now know, is a much more complex question. Open liquid water on the surface is not just a result of the correct distance. It is the result of geological, gravitational, and atmospheric history billions of years long. A planet must live this history correctly, or at least correctly enough. This history can unfold differently in other systems. Maybe the tectonics there are different, maybe fewer locks are needed, maybe other mechanisms are needed, but something performing their function must be there. And now the last question, which is rarely asked because it is a bit scary. What will happen to the Earth's oceans? The sun continues to flare up. Over the last billion years, it has become about 10% brighter. Over the next billion, it will become even brighter. In a few billion years, the temperature on the surface of the Earth will begin to go beyond the limits in which liquid water is possible. First, evaporation will intensify. Then water vapor will begin to accumulate in the atmosphere, launching that very greenhouse effect acceleration that we saw on Venus. The carbon thermostat will cope, but only up to a certain limit. When the sun becomes bright enough, the thermostat will not be able to compensate for the excess heat. This will happen not tomorrow, not in a million years. According to calculations, complex life on Earth has about 1 billion more years until conditions begin to become truly unfavorable. This is more than the entire history of animal life since the moment of the Cambrian explosion repeated again. No, in the ultimate end, Earth will repeat the fate of Venus, just significantly later. The story of water on Earth has a beginning and will have an end. Between them are almost 5 billion years of a liquid, warm, living ocean. In this window arose all types of life that have ever existed. Consciousness also arose, which asks the question of where water came from. We started with a paradox. Earth is too wet for its place in the solar system. It stands between two dead worlds, and at the same time splashes with oceans. Now we know what stands behind this. Not one miracle, but a chain of 7 interconnected conditions, each of which in itself is a rarity, and together they form something completely unusual. Water came from the asteroid belt, directed there by Jupiter. Part of it was here from the birth of the planet. The magnetic shield held the atmosphere. Tectonics adjusted the climate. The moon stabilized the axis. The orbit turned out to be in the right place, and the planet turned out to be large enough not to cool down ahead of time. All this together is not an accident and not a design. This is physics. No, physics in a very rare combination. Earth is a detective story that solved itself. From dust and ice, from collisions and explosions, from the migration of giant planets and isotopic traces in meteorites, a world with an open ocean under an open sky resulted. The only such world we know. If you are interested in such stories about how the universe works, why planets are so different, and what this says to us about our place in space, subscribe to the channel and give it a like. Every video here is one big question that we disassemble to the end, not rushing, not superficially, but so that in the end, the world looks a little different than before watching.